Ideal gas law notes example number 33. What is the molar mass, aka formula weight, of sulfur dioxide if 300 milliliters of gas has a mass of 0.855 grams at STP? So remember, the first question we ask ourselves every time is, do I have or need moles? No. Do I have or need mass? Yes. So then we would use the formula MVP equals GRT. Okay, so now we're going to start plugging things. Now, I do realize on this problem that you could calculate the molar mass just from your periodic table of sulfur dioxide, but that's not the spirit of this problem. The spirit of this problem is to go through and understand what to do if you were given something where you did not know what the chemical was and still could get the big M molar mass. So remember, big M is molar mass, V is volume, P is pressure, G is grams, R is the ideal gas law constant, and T is temperature. Also recall that we must have temperature in Kelvin and volume, or anything that has a volume in it, in liters because of the R constant. So we're going to start by saying M, which we don't know, times our volume. Now we need to convert that into liters. So that's going to be 0.300 liters. What did I do? I went from milliliters to liters. I did either you can do a conversion chart, or remember, when you're going from milliliters to liters, move it 3 to the left. Times pressure, and we're going to pick a standard pressure. You can pick any of the standard pressures. This problem doesn't specify one, so I'm going to pick 101.325 kPa. And then we're going to do mass, and I gave you the mass of 0.855 grams. And we're going to pick the R constant that matches with kPa, so 8.314 kPa liters over mole Kelvin. And then STP is standard temperature and pressure, so 273.16 Kelvin. I want to make sure I emphasize that the reason I picked 101.325 kPa is because of STP. I could have picked any of the standards. I chose to pick kPa. You could have picked a different one. Our answers should come out very close to each other. Also, I know that this STP tells me that I must use temperature of Kelvin. All right, so now we're going to crank that into our calculator and get an answer. Give me just a moment. I'm going to pause the recording. I'll be right back with you. I need to grab my calculator. Okay, I'm back. Before we pick up our calculator and do any calculating, we want to make sure that our temperature, or if we have any temperatures, they're in Kelvin, and if we have any volumes or anything with a volume unit, it's in liters. That's true. We have liters here, and we have Kelvin for temperature. And that is because liters here for volume must be true about liters, because I have the liters in K, and that's sort of a forced situation. So now I'm going to multiply the numbers on the right, because they're without an unknown. So the numbers on the right have no unknown. So I'm going to 0.855 times 8.314 times 273.16. It equals, divide by the numbers that are next to the unknown, or you can multiply both sides and divide to get unknown by itself. And you should get 63.88 with rounding 2 places past the decimal, and the unit would be grams per mole. 63.88 grams per mole. Ideal gas law example number 34. So I read through this problem just like we've done on all the other problems. The first thing I figure out is which formula I need. So do I have or need moles? No. Do I have or need mass? Yes, I have mass right here. So we're going to do MVP equals GRT. So our molar mass is of nitrogen, so that's going to be, remember, nitrogen is N2, so it's a diatomic because it's by itself, and so we're going to do 28.02 grams per mole. Actually, let me move that over so I have plenty of space to write. So 28.02 grams per mole. What did I do? I know the molar mass of one nitrogen is 1401, and there's 2 because it's diatomic. Volume, I got to have that in liters, so I need to move my decimal 3 times to the left to go from milliliters to liters, or I could also choose to do a grid. I'm looking for pressure. My mass is 56.0 grams. And I got to pick an R. In this case, it could pick any R, but this problem specifies that I want it in millimeters of mercury. So I need to do 62.4 millimeters of mercury liters per mole Kelvin. And then my temperature, there's my temperature in Celsius. I need to convert it into Kelvin. So 293.16 Kelvin. All right, so now I'm going to, before I pick up my calculator and do any calculating, I want to ask myself, do I have a volume? Yes. Is it in liters? Yes. Do I have a temperature? Yes, it's in Kelvin. So now I can proceed. We're going to multiply the three numbers on the right because they're without an unknown. So 56 times 62.4 times 293.16, hit equals, divide by the two numbers on the other side, or multiply them and then divide them over, or divide them over separately, and I get a pressure of 373.50 millimeters of mercury. And millimeters of mercury would be our unit because that would be the unit of pressure that we have left after all units cancel. Problem number 35, ideal gas law. So same as we've always kind of stated, first thing we're going to do is ask ourselves, do I have or need moles? No. Do I have or need mass? Yes. So I'm going to start with M. My formula will be MVP equals GRT. Okay, so then I'm going to look to see, I do have a formula weight. Remember, formula weight and molar mass mean the same thing. It's kind of an old school way of saying molar mass. Remember, molar mass is the same thing as your periodic table number. So we have a start here of molar mass of 62.5 grams per mole. Our volume is 0.372 liters. Got to move it 3 to the left or do a grid. It has to be in liters. Our pressure is 1067. I will have to pause. My pen is not communicating with my computer. Just one moment. I'll be back. Okay, so 1067 was what I was trying to write. Millimeters of mercury. On the other side, I have a mass, which is written a little weird. Sorry about that. I have a space there. My R is going to have to match in my millimeters of mercury. So 62.4 millimeters of mercury times liters over mole times Kelvin. And then T is what I'm solving for here. Before that looked like let's try that again. Okay, there we go, moles times Kelvin. Okay, so before I pick up my calculator and do any math, I want to ask myself, do I have a volume? Yes. Is it in liters? Yes. Do I have a temperature? No. So I don't have to worry about it. But I do know that my temperature will result in a unit of Kelvin. So my unknown is on the right this time, so I'm going to multiply the numbers on the left as I would in algebra class. Hit equals, divide by both of those numbers separately, or multiply them and then divide them over. And I get 496.95 Kelvin. Apologize for the writing. My computer is not talking to my pen very well. So 496.95 Kelvin is the answer for that one.